Swagatam Kapadi Mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 13th video on trigonometry chapter. In the 12th video, we derived the addition and subtraction theorems on sine, cos, tan, cot. Now in this video, I am going to do numerical questions based on addition and subtraction theorems. Now the question number 1. Prove that sine of a plus b times sine of a minus b is equal to sine square a minus sine square b. Now first one, I will take solution or proof. Take a left hand side. What is given? Sine of a plus b times sine of a minus b. And we know identities for this. Sine of a plus b, you have the first formula, sine a cos b plus cos a sin b times sin a cos b minus cos a sin b. Forget that these are the trigonometric terms. If you observe carefully, this is x plus y, this is x minus y form, algebraic form. X plus y times x minus y, you have the formula x square minus y square. Just apply this identity, we get sin a cos b whole square minus cos a sin b whole square. Now focus on right hand side. Right hand side, I have the expression only in terms of sine. That means whatever you have here, you have to convert all those cos terms into sine using the previous identities. The first one, we have sine square a, sin a whole square means sine square a, and this is cos square b. I can write, okay, I write one more step, I write cos square b minus cos square a sin square b. The next one, sin square a, I keep as it is. I don't want cos, so I convert into sine by using the identity cos square b is equal to 1 minus sin square b minus, I don't want cos square a also, I write sin square a 1 minus sin square a times sin square b. Now simply open the bracket. So you have sin square a minus sin square b, sin square a minus sin square a sin square b, sin square b into 1 sin square b plus sin square a sin square b. So one negative term quantity, one positive quantity you can cancel. You have sin square a minus sin square b. So I got right hand side. Now you can express the sin square a sin square b in terms of cos also by using, or I can write 1 minus cos square a minus 1 minus sin square b, so that I will get this 1 will get cancelled, so it will become you have cos square b minus cos square a. That means you can express this identity complete in terms of sine or in terms of cos. I will write here cos square b minus cos square a. Yeah, please take it. cos of a plus b times cos of a minus b is equal to cos square a minus sin square b. Same, take left hand side. Cos of a plus b e times cos of a minus b. Method is similar, just apply cos of a plus b identity. You have cos a cos b minus sin a sin b times cos a cos b plus sin a sin b. And here also you can apply the identity x minus y times x plus y is equal to x square minus y square. Same identity I am writing. So here I will get cos a cos b whole square minus sin a sin b whole square. Now our next steps are always depends on what the results we need. Now here my expression in terms of cos square a and sin square b. But here I have both cos a cos b sin a sin b. That means I don't want cos square b and I don't want sin square a. So I need to focus on these two. How I can convert cos b in terms of, already you know it, that is cos square a, and cos square b can be written as 1 minus sin square b, because I don't want cos square. Same way I don't want sin square also, I can write cos square a times sin square b. Just open the bracket, you get cos square a minus cos square a sin square b minus 1 into, this is sin square b, minus into minus plus cos square a sin square b. Now this negative quantity and the positive quantity equal, they are same, we can cancel. So we have cos square a minus sin square b. We got right hand side. Now I can express this in different way also. How? Look here, or I can write 1 kind of cos square a as 1 minus sin square a minus 1 minus cos square b. If you open the bracket, you get cos square b minus sin square a, cos square b minus sin square a. This 1 will get cancelled. That's also you can write cos square b minus sin square a. Yeah, the proof is over. Next one, find the values of sin 75 degrees, cos 75 degrees, tan 75 degrees, cot 75 degrees, sin 15 degrees, cos 15 degrees, tan 15 degrees and cot 15 degrees. Now one by one we do. Of course I am going to use this addition and subtraction theorems to find these values. So first one, solution. Sin 75. Now sin 75, how we can do? Very simple. I write 75 as 45 degrees plus 30 degrees, because I know sin 45, sin 30, cos 45, cos 30. That means whenever we need to find the value of trigonometry ratio for an angle, you have to express that angle as sum or difference of known angles for which trigonometry ratios are known. This is the method this is. So I expressed this as 45 plus 30. Simply I go for identity. Sin 45 cos 30. Sometimes I may miss putting this symbol degree, please excuse me. Plus cos 45 and sin 30. Now sin 45 we know very well value 1 by root 2 and cos 30 is root 3 by 2 plus cos 45 is 1 by root 2 and sin 30 is 1 by 2. On simplification you get root 3 plus 1 by 2 root 2. Please note it down. Now similarly next one I will go for immediately cos 75. And as usual cos 75 I am writing this as cos 45 plus 30, same formula I am going to write here cos 75 cos 30 minus cos 45 sin 30 and substitute values. Cos 45 is nothing but 1 by root 2 and cos 30 is also root 3 by 2 minus sin 45 is 1 by root 2 whereas sin 30 is 1 by 2. If you simplify this you get root 3 minus 1 by 2 root 2. Then come to next one, third one, tan 75. Of course tan 75 is nothing but sin 75 by cos 75. Either you can use that identity or okay I will go for identity only. Tan 75 is equal to tan of 45 plus 30. So this is nothing but tan 45 plus tan 30 upon 1 minus tan 45 into tan 30. Now substitute the values, we get tan 45 is 1 plus root 3 1 over root 3 by 1 minus 1 times 1 over root 3. If you simplify you get root 3 plus 1 over root 3 minus 1. In general we do not leave the denominator as an irrational number. So in this case we have to rationalize the denominator always. So for this what I do like this, root 3 plus 1 over root 3 minus 1. I am going to multiply both with the conjugate of this, that means I am multiplying with the root 3 plus 1. So the numerator is root 3 plus 1 whole square. So we get 3 plus 1 plus 2 root 3 and this is a minus b into a plus b, root 3 square minus 1 you will get to 2. On simplification we get 3 plus 1 4, so we will get a 2 plus root 3. Therefore tan 75 is equal to 2 plus root 3. Next I am going to do cot 75. Cot 75 as usual I am going as a cot of 45 plus 30. Cot of a plus b formula you have cot 45 cot 30 minus 1 by cot 30 plus cot 45. I am using cot a cot b minus 1 by cot a cot b plus cot a. Now substitute values, you have 1, cot 30 is root 3 minus 1 by same thing root 3 plus 1, and you cannot leave this. If you rationalize it you will get 2 minus root 3. So I derive first 4. If you know the first 4, deriving second 4 is very simple. Yeah, please take it. Sin 15, cos 15, tan 15 and cot 15. Very simple these are. The fifth question, in one line we can prove it. Sin 15, I will write sin 15 as, I can do subtraction using subtraction formula. but I don't want to use that one. I want to go for another way. 15 can be written as 90 minus 75. And sin 90 minus theta is nothing but cos theta. Sin 15 and cos 75 complementary. And you know what is cos 75 value? Is nothing but root 3 minus 1 by 2 root 2. Just we derived. So in the one line we got the proof. Otherwise you can do sin 15 as sin of 45 minus 30, apply the identity, then substitute the values, then you will get the answer. Next one, come to sixth one. We are smart people, so we have to use smart method. This is 90 minus 75 is nothing but sin 75. Of course I know this value, root 3 plus 1 by 2 root 2. Similarly, tan 15, seventh question. Tan 15 degrees is equal to tan of 90 minus 75, which is equal to cot 75, just now we proved as 2 minus root 3. And next, eighth one. Cot 75, you can guess it as tan 15. Right? Cot, sorry, we want reverse. Cot 15 is equal to tan 75. Just now we proved as 2 plus root 3. So we did all these ones. Yeah, please take it. Next question is, if sin alpha is equal to 3 by 5 and cos beta equal to 9 by 41, you have to find the values of sin of alpha minus beta and cos of alpha plus beta. Now I am following the order of the textbook written by S.L. Loney. The title is Plane Geometry. Again repeat, I am following the textbook Plane Geometry written by S.L. Loney. So if you want the questions, you can refer the books, and all these books are soft copies are available on online, no need to purchase also. And I can say, if you learn trigonometry from this book, definitely you will get good hold on this chapter. You know one thing, and this Srinivasa Ramanujan, great mathematician, also inspired by this book. So my suggestion is, if you want to learn trigonometry thoroughly, just follow the textbook for theory part as well as the numerical part. Now come to the question. Yeah. Sin of alpha 3 by 5, cos beta is 9 by 41. And I assume that since sin alpha is positive, cos beta is also positive, I assume that this alpha and beta are acute angles. Of course, these are the proof for any time, but I assume that one. So in this case, what to do? My technique is solution. Very simple. I draw a right angle triangle. Let's say A, B, C, and this angle is alpha. And has sin 3 by 5 is given. Of course, this is opposite side by hypotenuse. By Pythagoras theorem, I can find this value. It is nothing but 4. Now proudly say, this is not a Pythagoras theorem. It is Baudhayana. Just 100 years before the Pythagoras, our great Indian mathematician Baudhayana, he introduced this theorem, not Pythagoras theorem. I can say very strongly, I believe that this is not Pythagoras theorem, this is Baudhayana theorem. So using the Baudhayana theorem, I will get the 4. Of course, different formats. Next one, similarly for the second one also, I will draw one more right angle triangle. I will go for this as PQR. Here 9 by 41 is given. Of course, this is 9 and this is 41. By using Baudhayana theorem, I will get this as 40. And this angle is equal to beta. Now, from this right angle, proving this is very easy. Okay. Now, I will go for sin of alpha minus beta. You know the formula? Sin alpha cos beta plus minus cos alpha sin beta. Now substitute the values. Sin alpha One more question. Prove that cos 45, first question, cos 45 minus a times cos 45 minus b minus sin 45 minus a times sin 45 minus b is nothing but sin of a plus b, and it is true for all the values of a and b. Okay, first one. I will take left hand side one. Is cos 45 minus a 45 minus b minus sin 45 minus a minus b. Now, if you look at carefully, it looks like an identity. I will take this as some a, this is b, this is a again, this is b. Looks like cos a, cos b minus sin a, sin b, which is an identity. So, I can write it as cos of, it looks like cos a cos b minus sin a sin b is equal to, you have cos of a plus b. Okay, now apply this identity, we get cos of a is nothing but 45 minus a and b is nothing but 45 minus b. Bring the numericals together, 45 plus 45 90, so you have cos of 90 degrees minus minus a minus b, bring minus common, you have plus b. Now this again cos of 90 minus theta form, and you know cos of 90 minus theta is equal to sin theta. Here theta is a plus b, so we get cos of theta is a plus b, so a plus b. Oh, we got answer, right hand side. Yeah, prove. Similarly, you can prove the second one. It looks like sin a cos b plus cos a sin b is formula is sin of a plus b. Again bring 45 together, a and b together, you get that expression. Next question, prove that sin of a minus b by cos a cos b plus sin of b minus c upon cos b cos c plus cos of c minus a upon cos c cos a is equal to 0. So, we have to take term by term and you have to simplify them, then you have to add all the three results, then you have to check whether you are going to get 0 or not. Simply just applying the identities, you will get the answer. So, what I do, I take the first term, solution or proof. Take first one, sin of a minus b by cos a cos b. I will do slowly. Sin of a minus b formula, you have sin a cos b minus cos a sin b over cos a cos b. Now split into two fractions, we get sin a cos b by cos a cos b minus cos a sin b by cos a cos b, and cancel the common factors, cos b common factor here, cos a cos b common factor here. So, here we have sin a upon cos a is nothing but tan a, and sin b upon cos b nothing but tan b. So, my sin a minus b, ab, cos a cos b converted into tan a minus tan b. So, no need to do second and third. Similarly, I can write sin of b minus c upon cos b cos c automatically will become BC. So I'll write this as tan B minus tan C. Order also same. Next one, and finally, oh, this is sine. This is sine. Sine of C minus A by cos A is nothing but tan C minus tan A. Now you have to add all. Therefore, sine of A minus B upon cos A cos B plus sine of B minus C upon cos B cos C, sine of C minus A upon cos C cos A is equal to first one tan A minus tan B plus tan B minus tan C plus finally I got tan C minus tan B. Now if you observe carefully, I have positive tan A and negative tan A. I have negative tan B, positive tan B, minus tan C plus tan C. Everything let cancel, we get answer 0, which is equal to RHS. Hence proved. Yeah, please take it.